subject. Okay, irrespective of specialization. My specialization is organic chemistry. Right. Today we are going to discuss about organic spectroscopy. So how can we identify the molecular structure of the compounds? So for that purpose, here I'm going to discuss about organic spectroscopy. Yeah, right now I'm going to ask one question. So after that, I'll explain the different kind of molecular spectroscopies. Right. So now, first of all, what one question here. So what is chemistry and what is the importance of chemistry? Anybody, you can share that answer. What is chemistry and what is the importance of chemistry? Because all are chemistry people, right? So any one of you? Unmute
Good evening, sir.
Yeah.
Myself Swati.
Yeah. What is chemistry?
It is one of the science branch. We are dealing with one of the science branch. This is. And also we are studying the properties, compositions, interactions, all the things we are studying in chemistry.
Sir.
Yeah. Okay. Right.
Okay, thank you.
So yeah. Thank you.
Good evening, sir.
Good evening,
Myself, Monica.
Monica.
The chemistry meaning is group of chemicals, sir.
Group of chemicals. Right.
Good evening, sir.
Yeah.
Thank you, sir. Good evening, sir. I am Samata.
Okay.
Behavior of substances, sir.
Behavior of substances. Right. So in if we consider different people, so in each of mind, one set of definition is there. All right. Chemistry is nothing but it is deals with the chemicals, and it is nothing but a branch of science, right? So here exactly what is the definition of chemistry? Here the chemistry is a branch of science which deals with it deals with the investigation of chemical compositions. Deals with investigation of a chemical composition. Is it right? Chemical composition. What type of composition is present in a substance, and what is its geometry? So this is a definition of chemistry. Chemistry deals with the investigation of chemical composition and its geometry. So in order to find out the geometry of substances, we can use different types of methods. That is, we can assess the chemical properties. We can assess chemical properties and physical properties of a compound. So the properties of compounds can be assessed or analyzed by using a heading. That heading is considered as a chemistry. So this is a definition of chemistry. All right. So the branch of science which deals with the investigation of chemical composition and its geometry. The geometry and composition both can be assessed by using their chemical and as well as physical properties. In sometimes we can use biological properties also. Biological properties. So with the help of these, we can assess the chemical composition and as well as geometry of the molecule. A well and a known example, all of you well known to this one, water. Do you know about water? What is the chemical name of water?
H2O, sir.
Chemical name. Name of water. This is a general name. What is the chemical name?
Hydrogen monoxide.
Hydrogen monoxide, right? So its chemical formula already well known, water, H2O. All right. So the composition of water is, what is the composition? 2:1 ratio of hydrogen and oxygen by elemental form. This is according to elemental form. By weight, what is the ratio? 1:8 ratio of hydrogen and oxygen present in water. This is a chemical composition of water. How can we identify this chemical composition? The chemical composition of water is analyzed by using weight percentage method. So this is a elemental analysis. Is it right? By using elemental analysis, we can find out the chemical composition of any kind of substances with the help of elemental analysis. Right? So this is one of the investigation method. What is our definition? It deals with the investigation of chemical composition and the geometry of the different kind of chemical substances present around us. So here, the chemical analysis, how can we analyze the chemical composition? By using elemental analysis. So in the elemental analysis, we have different methods. One is percentage weight method, percentage mass, percentage volume, right? Volume, mass to volume ratio. Like that, we can find out the elements, what type of elements are present in a given substance. This is one of the investigation process. And the second one, in the definition we discussed, one is chemical composition. How can we identify the chemical composition? The chemical composition is analyzed by which method? How can we analyze the chemical composition of any substance?
Element analysis, sir.
By elemental analysis. By elemental analysis.
Yes, sir.
We can find out either there is a percentage mass, percentage volume, volume to mass, mass to mass. Like that, the different methods are there. By using that, we can find out the chemical composition. This is one of the methods, right? And the second one is here. The second investigation is a geometry. How can we identify the geometry of a substance? What are the methods we can use to identify the geometry? Yes. What is the geometry of water? Geometry of water. Yeah. Yeah. The geometry of water is V shape. V shape or angular shape. Or bent shape.
Bent shape.
Yeah, this is the shape of a water molecule according to a chemical person or a chemical knowledge. Otherwise, the geometry of water is when we taken water in any container, that is the shape of the water. Is it right? If you don't know the chemistry, so what is the geometry of water? So if we take the water in a cup, the geometry of water is cup, the shape of water is cup or bottle, like that, right? But the exact geometry of water is V shape or angular shape or bent shape. How can we know the shape of a molecule? What is the method? What is a method to identify the geometry of molecule?
By the whisper theory.
So the simplest method is one of the method, that is hybridization. So this is the simplest method, hybridization, according to VBT and Vesper theory. We can analyze, that is a hybridization method, one of the method, simplest method to know the geometry of the molecule. In case of water, the geometry hybridization of water is sp3 hybridization.
SP3 hybridization.
sp3 hybridization with 2 lone pairs and 2 bond pairs. 2 lone pairs and 2 bond pairs. sp3 hybridization with 2 lone pairs, 2 bond pairs, the geometry is V shape or bent shape. If the hybridization is sp3 and it has one lone pair and three bond pairs. What is geometry? What is the geometry? If hybridization is sp3, it has one lone pair and
Pyramidal.
three bond pair.
Triangular.
Pyramidal,
Trigonal.
pyramidal geometry, pyramidal.
Pyramidal.
Yeah. sp3 hybridization, it has only four bond pairs. The geometry is
Tetrahedral.
tetrahedral geometry. So this is one of the method to know the geometries of molecules with the help of hybridization. We find out the geometry of molecules. So this is the definition of a chemistry. What is a chemistry? A branch of science which deals with the investigation of chemical and geometries. So once we know the chemical composition and the geometry of the molecules, we can utilize those materials in a proper way. If we don't know the chemical composition and we don't know the chemical properties, we can't use that material in a better way, right? So for that purpose, we can study the chemistry to know about the chemical composition and the structure of the components and their utilization. We are going to study the chemistry. So this is about the basic introduction regarding to the chemistry. I'm not going to elaborate this in detail. Is it clear? Yes?
Yes, sir.
Yeah. So that is about hybridization. So there is any other methods to identify the geometry of molecules other than hybridization? Other than hybridization, how can we identify the geometries other than hybridization? There is any? Yes?
Whisper theory.
Vesper theory. Yeah, okay. Right. One more question. I have one more question. What is the geometry of sulfur dioxide? How can we identify the geometry of sulfur dioxide?
Linear shape.
Yes?
Linear.
Spherical.
Spherical? So how can we identify? Now I explain. By using a simple method, this hybridization method only, I can identify the geometry of this molecule. Okay. So to find out the hybridization of any molecule, we can use this formula of into group number of central atom and number of monovalent atoms which are surrounded by it. If it is a charged one, cation, we can remove that charge. If it is anion, we can add that charge. So we get a value that x, this is a x, is a value. If x is equal to the hybridization is sp, then the geometry is, what is the geometry of sp hybridized orbitals?
Linear.
Linear geometry. Yeah.
Shape.
If x is equal to 3, sp2 hybridization, what is the geometry?
Triangular planar.
Trigonal planar. I am going to represent in the short form TP. If it is 4, hybridization is sp3. The geometry is tetrahedral geometry. If it is 5, sp3d. Yes.
Trigonal
Trigonal
tetrahedral.
Trigonal bipiramidal. Yeah, 6 sp3d2 or d2 sp3. So this is octahedral geometry, right? Okay. So this is a method. So sulfur dioxide. Here I am going to find out the geometry of sulfur dioxide. So sulfur, what is the group number of sulfur? Sulfur belongs to 6th group, right? Yeah. How many number of monovalent atoms are surrounded?
0.
Number of monovalent atoms.
0.
Yeah. Here the monovalent atoms are nothing but first group elements.
Yes.
And 7th group elements. These only monovalent. The remaining all are not monovalent. Is it clear? The first group elements are monovalent. 7th group elements are monovalent. First group element, for example, taken as hydrogen. This is a monovalent. Sodium is a monovalent. Lithium, monovalent. Seventh group elements, fluorine, chlorine, bromine, iodine. If these are surrounded, those are considered as monovalent atoms. So now around the sulfur, there is any first group or seventh group element? Yes. Number of monovalent atoms are 0. Is it clear?
0.
Yeah. There is any
0,
charge on
0.
yeah, there is any charge on this molecule?
No charge.
No, this is a neutral molecule. There is no charge. So half into 6 means 3. 3 stands for sp2
sp2.
hybridization. What is the geometry of this molecule?
Geometry trigonal planar.
Trigonal planar. What about SO3?
SO3.
Linear.
SO3. Same geometry.
Trigonal planar.
Yes, the same geometry, trigonal planar, because there is no monovalent atoms. Only the sixth group element sulfur. 6 by 2 means 3. Is it clear? So like that, we can find out the geometries of molecules. This is one of the simple method find out the geometries of molecules. Without any instrument, we can assess the geometry of molecule by using this simple way. Right? Other than this way, we have different methods are there. One of the method is dipole moment.
Sir, could you give one example for monovalent atom?
Monovalent atom, right? So here the monovalent atoms, yeah, okay. I'll go with one another example, right? NH3. What is the geometry? What is the hybridization of ammonia?
Ammonia.
Yeah.
Pyramidal shape, sir.
Yeah,
sp2 hybridization.
yeah, well known to us, right? I'm going to use the formula half. What is the group number of nitrogen?
7.
5.
Nitrogen is the fifth group element.
Group element.
How many monovalent atoms are there?
3.
3.
4
5
atoms.
plus 3, 8. Yeah, 8 by 2 means
4.
4. 4 means
Hybridization.
sp3 hybridization. Right? Here, the nitrogen has fifth group element. It has a lone pair electrons. Okay. So already we discussed here the point according to Vesper theory, 2 lone pairs, 2 bond pairs. What is geometry?
V shape, sir.
V shape. 1 lone pair, 3 bond pairs. Geometry.
Pyramidal shape.
Pyramidal shape. So here now 3 bond pairs are there. Plus 1 lone pair is there. So total that is 4 pairs. 4 pair means once again it is sp3 hybridization. But the geometry is, what is the geometry? Pyramidal.
Pyramidal.
Is it clear? Okay. So I'm going to write one more example here. H2SO4. What is the geometry of central atom? What is the hybridization of central atom?
H.
Central atom is sulfur.
I think it's tetrahedral.
S.
sp3, sir.
Yes.
Yes, sir.
sp3
Yeah.
hybridization.
Sulfur. What is your group number?
6.
6. Number of monovalent atoms?
4.
2.
4.
2. 2.
2, sir.
Oxygen is not a monovalent, it is a bivalent. 6 plus 2, 8. 8 by 2, 4. Once again, it is a 4 means sp3 hybridization.
sp3.
Is it clear?
Yes.
Yeah. So what is the geometry? What is the hybridization of CH3 plus?
Methyl.
CH3 plus hybridization.
Trigonal planar. sp3 hybridization. Sorry, sp2.
sp2. Yes, it is sp2 because half into 4 plus 3 atoms minus. If it is a plus 1 charge means we can remove that. Minus 1. Clear?
4 minus 2, 6.
6 by 2 means 3.
6.
3 means sp2 hybridization.
Yes.
So that's why the methyl, that is carbocation, is always sp2 hybridized carbon atom. Yes? Is it right?
Yeah, clear, sir.
Yeah. So by using that, we can find out the hybridization. Once we know the hybridization, we can find out the geometry of molecule. Right? So other than the...
Sir,
Yeah.
if you don't mind, your voice is not audible, sir.
My voice is not audible.
No, sir, it's clear.
Yes, clear, sir. మీకే ఏదో ప్రాబ్లం అనుకుంటా మేడం.
Yeah. If you have any network issue, then it will be happening. Yeah. Is it clear?
Yes, sir. Yes.
Clear.
Yeah.
Yes, sir.
So this is one of the method how to find out the geometry and as well as hybridization of a molecule. Other than hybridization, we can use the one other method, that is dipole moment. With the help of dipole moment also, we can find out the geometry of molecules, right? So dipole moment, that is mu is equal to 0 or mu not equal to 0. These two are the concepts. Simply, mu is equal to 0. If it is 0, dipole moment value is 0, that molecule is considered as a polar molecule and it has a regular geometry. Regular geometry, that is irregular geometry. Mu is not equal to 0. 1 minute. Mu is equal to 0, that is non-polar. Mu not equal to 0, that is a polar molecule. The polar molecules has a irregular geometry. Non-polar molecules has a regular geometry. How can we can find out the polarity or non-polarity? Now we discuss. So simply, I am going to take an as carbon tetrachloride. This is a polar or non-polar?
Polar, sir.
Yes. Is this polar or non-polar?
It's polar.
Non-polar.
Yeah.
Non-polar.
So,
Non-polar.
yeah, this one is non-polar molecule. Non-polar. Water molecule is polar or non-polar?
Polar.
This is a polar molecule, right? Simple example. This is a polar molecule. This one is a non-polar. So what is our condition? If it is a non-polar, it has a regular geometry. The geometry is a regular geometry. If it is polar, the geometry is irregular geometry. So what is the difference between regular geometry, irregular geometry? Now we discuss. So sp3 hybridization, what is the geometry?
Tetrahedral.
So this is a regular geometry. Tetrahedral is a regular geometry. Tetrahedral is a regular geometry. If sp3 hybridization with a pair of electrons, what is the geometry?
V shape, 2 bond pairs, 2 lone pairs. That is the V
Yeah.
shape.
Yeah, that is considered as an irregular geometry. Clear? So here the CCl4, what is the hybridization? CCl4. Yeah,
sp3.
hybridization.
sp3, sir.
sp3 hybridization, because carbon is with a 4 group number. We have 4 monovalent atoms. 4 plus 4, 8 by 2. That means 4. 4 is a sp3 hybridization. So it is with the sp3 hybridization. So the regular geometry is tetrahedral geometry. This becomes non-polar molecule. Water molecule, it is also with sp3 hybridization, but it is a polar molecule. It has a irregular geometry. The geometry is V-shape or bend shape. Clear? This is a one another method, the simple method to find out the geometries of molecules. Is it right? Okay.
Yes, sir.
Yeah. So this is one of the method, the geometry. How can we identify the geometries of molecules? So these are the simple methods which are deals with the some calculations, or by using some basic knowledge, we can identify the geometries with the help of hybridization or dipole moment, etc. Yeah, and one more thing, we can use the melting point and boiling points also. With the help of melting point and boiling point also, we can assess either that is a ortho substituted or para substituted molecule. We can differentiate the molecules with the help of that boiling points and melting points. That one also one another method. Is it clear? So in our hands, if there is no instrument, simply we can use this type of methods. Either it has a geometry, regular geometry, or irregular geometry. So these are the simple methods. Without instrument, we can assess. But a big question arises when we take as a big molecule. If molecule is vitamin, in case of vitamins, in case of steroids, so we can't assess the geometry of molecule and its a composition with a simple manner. If we use the simplest methods to assess the geometry or composition of molecules, then what happened? There exist some kind of errors. The accuracy of the assessment is decreases. That is one of the biggest problem in case of simple methods by using simple methods to identify the geometries. So in order to overcome that problem, we can use one of the method. That method is a spectroscopic method. Spectroscopy. So what is a spectroscopy?
The interaction of magnetic interaction in between the substance.
Yeah. Okay. So is it okay? Language Telugu kuda use cheyala?
No, sir, not.
No, sir. No, sir.
Everyone.
Okay, sir.
Yeah. Okay. Okay. All right. So spectroscopy. What is a spectroscopy? What type of spectroscopic methods are there, and what type of molecular spectroscopies are there? Now we discuss. So spectroscopy, a simple method. This is a interaction of electromagnetic radiation. Electromagnetic radiation. This is interact with the sample molecule. It is interact with the sample molecule. With these interactions, either in the sample the changes takes place. We can observe the changes which are happens in the sample, and at the same time in the electromagnetic radiation also the changes are takes place. We can study the changes happens in electromagnetic radiation and as well as sample. Simply, this one is a lorry, this one is a bike. So when a lorry with a overspeed collides with the bike, then what happened? There are changes we can observe in bike and as well as in a electromagnetic radiation. That means lorry. Is it clear? So based on these changes, we can study what type of changes that can happen in the sample and what kind of changes that can happen in the electromagnetic radiation. And based on those changes, we can find out the geometry of the molecule, the shape or composition of the molecule. So that study is called as spectroscopic studies. Spectroscopic studies are nothing but interaction of the study of interaction of electromagnetic radiation with a sample. So that study is called as the spectroscopic studies. In spectroscopic studies, we can find out the chemical structure, the skeleton structure, chemical composition or structure. We can assess. So that is the definition of spectroscopy. How many types of spectroscopies are there? Known spectroscopies.
So two types, absorption spectroscopy, emission spectroscopy. In this also types are there.
Yeah. So here the types of spectroscopy. So simple thing here, what we discussed, the changes which are happens in electromagnetic radiation and the changes which are happens in sample. So what type of changes we can expect in sample molecule? The changes in sample molecules are number one. So when the electromagnetic radiation is interact with the sample, within the sample molecule, we have electrons are present. Those electrons are excited from lower energy level to higher energy level. So that is called as electronic excitation. That means electronic transitions can be takes place. So these electronic excitations within electronic energy level. Electronic energy level. So how many electronic energy levels are present? Electronic energy levels. So for example, if you take them as an atom, once we consider if it is not a sample, the sample becomes an atom. So in case of an atom, what happened? Within the atom, the electrons are revolved around the nucleus in different electronic energy levels, like s orbital, p orbital, right? So first level, that is kth shell, lth shell, mth shell, like that. The different electronic energy levels are present. In that electronic energy levels, the excitation can be takes place. So that is about one kind. If it is a molecule, when we consider the molecule, in case of molecule also, we have a different kind of energy levels, that is bonding molecular orbitals and as well as anti-bonding molecular orbitals are exist. So within that electronic energy levels, the transitions can be happens. Right? So that is one of the change we can observe in the sample. And one more observe, that is change. Either that atom will undergoes rotation, means in the rotational energy levels, this transition can be takes place. So what type of changes? Either that sample undergoes rotation, this is one of the expectation, or the electronic excitation that will be happens in between the electronic energy levels. And a third kind of change, within the sample molecule, the vibrations and rotations will be happens. So vibrations and rotations means in the vibrational energy level and rotational energy levels, the molecule will be or the sample will be rotated or vibrated. So vibrations, rotations, and electronic excitations. These can be observed in case of sample molecule. And also in some cases, that sample molecule can undergoes the stereochemical change. Means the plane polarized light will be rotated. The specific rotation, PPL rotation or specific rotation we can observe. This is one of the change we can observe in the sample molecule. So once the electromagnetic radiation interact with the sample, within the sample, the lot of changes we can observe. One of the changes, electronic transitions. Other type of transition is rotational energy levels. And the third one is vibrations and as well as rotations, both can be happens. This is what happened, polarized light will be rotated either in a right direction or left direction. That is considered as a dextro or levorotatory, that is studied under the heading of stereochemistry. Right? So there is one more change that will be happen. Here the fifth type of change that we can observe in the sample, that is phosphorescence. Phosphorescence or fluorescence. So this is one of the physical interaction. So by that, what happened here, the excitations are not chemical transitions. So with the excitation, that excited nuclei or molecule come back to original level with the release of energy, same electromagnetic radiation with a short duration or instantaneously. If it is a short duration, that is called as phosphorescence. If it is instantaneous, that is called as fluorescence. So see, these are the some kind of changes that will be happens in case of a sample molecule. So what type of changes that will happens in electromagnetic radiation? The type of changes in electromagnetic radiation. What are the types of changes we can observe in electromagnetic radiation? Yes, anyone can answer it. The changes observed in electromagnetic radiation. Yes. Yeah, the changes we can observe in electromagnetic radiation. One is that electromagnetic radiation is reflected back. We can observe one thing, that is a reflection, right? This is one of the change we can observe, and we can observe that is absorption we can observe emission. We can observe refraction. We can observe scattering. These are the different kind of changes that will happen in electromagnetic radiation. All right, in electromagnetic radiation, these are the changes. So one of the changes is reflection, that is the light radiation is reflected back. So absorption means the electromagnetic radiation that will be enters into the bulk of the sample. Emission, in the absence of the electromagnetic radiation, so the radiations are emitted from the sample molecule in the absence of source. Initially, the source is present. In the presence of source only, the absorption takes place. In the absence of source, the absorbed radiations will be comes outside from the sample, that is considered as an emission. Refraction, the path of the light will be changed, that is called as refraction. Scattering, the emission of radiations other than 90 degrees, that will be considered as the scattering phenomenon. So with the help of that, these are the changes. With the help of these changes, we can study the spectroscopy of different kind of sample molecules. Right. So based on this, we can categorize the spectroscopy into two kinds. So one is a emission spectra, the other one is a absorption spectroscopy. So the spectroscopy is of two types. Spectroscopy is of mainly two types. One is a emission spectra. This emission spectra is considered as a atomic spectroscopy. Emission spectroscopy is called as atomic spectra. The second one is absorption spectroscopy. This is considered as a molecular spectra. This is a molecular spectra, right? One is a emission spectra, the other one is a absorption spectroscopy. Emission spectra is also called as atomic spectra. Absorption spectroscopy is also considered as a molecular spectra. So here the emission spectra, why it is called as atomic spectroscopy means the emission spectra is given by only atoms. Atoms gives the emission spectra. So well known to us in case of hydrogen atom spectra, hydrogen atomic spectra. So the hydrogen atom absorb the radiations, electromagnetic radiations are absorbed by the hydrogen atom, but with one electron containing atom. So that excitation will be takes place. The electron is excited from lower energy level to higher energy level. So when it comes back to its original level, it emits the radiation. By that we get the series of lines. Those series are called as Lyman series, Barman series, bracket series, Fund series, etc. So those are the different kind of series. So in emission spectra, we get the lines. Absorption spectroscopy, this is also called as molecular spectroscopy. This absorption spectroscopy is given by molecules. So that's why this is called as molecular spectroscopy. That is considered as a molecular spectroscopy. So these molecular spectroscopies are of different kinds. Different molecular spectroscopies are there. One is a microwave spectra, IR spectroscopy, UV spectroscopy, Raman spectroscopy, and NMR, electron spin resonance spectroscopy, mass spectroscopy. So those are all different kinds of spectroscopic techniques are there. So we will discuss those in the next session. If you have any doubts, you can ask questions.